Greetings, everybody. In this particular problem, we're asked to approximate an integral, a function expressed as an integral, by using term-by-term integration of a Maclaurin series of the Integrand. So let's delve into this problem and see what we can do. So we first look at the integrand of our function. So we see a 1 over the square root of 1 minus t squared. Well, in looking at that, we can see 1 minus t squared to the negative 1/2 power. And so that tells us we can do a binomial series expansion. So we want an expansion from n going from 0 up to infinity of a minus 1/2, choose n, and then inside this function, we're plugging in a minus t squared to the n power. So what that gives us is our series expansion, n equals 0 up to infinity of a minus 1/2, choose n, a minus 1 to the n power, and then a t to the 2n power. Well, we can approximate this with the first 4 terms of our series, which is going to give us a minus 1/2, choose 0, minus a minus 1/2, choose 1, times t squared, plus a minus 1/2, choose 2, t to the 4th, and then finally a minus 1/2, choose 3, t to the 6th power. So now we can just plug in our formulas for our binomial coefficients to see what this expansion looks like. So with our binomial series, if we have negative 1/2, choose 0, we know that's defined to be 1. Our minus 1/2, choose 1, looks like a minus 1/2 minus 0 over 1 factorial, or just a minus 1/2. Our minus 1/2, choose 2, gives us a minus 1/2 minus 0 times a minus 1/2 minus 1 all over 2 factorial. So this will simplify to a 3/8. If we have a minus 1/2, choose 3, that will give us a minus 1/2 minus 0 times a minus 1/2 minus 1 times a minus 1/2 minus 2, all of that divided by 3 factorial. And that will simplify to a negative 5 over 16. So taking these values and then plugging them into our series expansion is going to give us, so then doing the approximation for our function, 1 over the square root of 1 minus t squared is then going to give us approximately, from our previous approximation, gives us a minus 1/2, choose 0, minus a minus 1/2, choose 1 times t squared, plus a negative 1/2, choose 2, t to the 4th, and then minus a minus 1/2, choose 3, t to the 6th. So if we plug in the values that we just obtained a second ago for our binomial coefficients, we see that this is going to be 1 minus a minus 1/2 t squared plus a 3/8 t to the 4th minus a negative 5/16 t to the 6th. And so that's, when we simplify, that's going to give us a 1 plus 1/2 t squared plus 3/8 t to the 4th, and then plus 5/16 t to the 6th. If we have our function now, f of x, being the integral from 0 up to x of 1 over the square root of 1 minus t squared dt, then this is going to be approximately our integral from 0 up to x of the 4 terms of our series. So 1 plus a 1/2 t squared plus a 3/8 t to the 4th, and then plus a 5/16 t to the 6th dt. So this is going to give us a t plus a 1 over 2 times 3 t cubed plus a 3 over 8 times 5 t to the 5th, and then plus a 5 over 16 times 7 t to the 7th, evaluated between 0 and x. So when we make this substitution, what we find is that this is going to be our x plus a 1/6 x cubed plus a 3/40 x to the 5th, and then plus a 5 over 112 x to the 7th. So therefore, with our function f of x approximated by x plus 1/6 x cubed plus 3/40 x to the 5th plus 5 over 112 x to the 7th, if we plug in f of 1, what we obtain is 1 plus a 1/6 plus 3/40 plus 5 over 112, which gives us 2,161 divided by 1680, or approximately 1.286309524. So I hope you've enjoyed this approximation or this example, and I will see you guys in the next one. Bye.